All right, what's up, everybody? Just wanted to get back in here to give a quick video to talk about the membranes of the body. So I'm not going to waste any time. I'm just going to go ahead and jump right on into this and get into the screen capture here, screen share, and bring up our notes. On the tissues on slide 48, starts telling you a whole bunch about body membranes. And it talks about the fact that basically you form a body membrane by combining two different tissues. You combine epithelial tissue and connective tissue. Now stop for a minute. If you combine epithelial tissue and connective tissue, you really need to think about the functions of those two tissues and what you're combining. Remember, epithelial tissue is to line and cover and protect something. Connective tissue is usually to connect something. A lot of times it's used to connect epithelial tissue to other tissues. So keep that in mind when you're looking at what membranes do. Notice that they line body cavities. They cover viscera. When you say cover viscera, you're saying that they cover internal organs. They cover internal tissues of the body. They can cover the body's external surface, so you're outside. And there's four different types of membranes. There's mucous membranes, serous membranes, cutaneous membranes, and synovial membranes. Now, mucous membranes, the first one. Sometimes we will refer to mucosa. So don't be fooled when you see mucosa and mucous membranes. Oh, FYI. One thing about anatomy and physiology that really ticks people off, and I don't blame them, is that in anatomy and physiology, we oftentimes have things that are, it's one thing, but it has multiple names. Kind of like me. You know, my name is Julian. Some people know me as Julian. Some people, like my friends from up north, they call me Juju or Juju Bean. My boys from back in the day call me Stretch. Other students know me as Professor Nixon. Either way, I'm the same guy. I just have different names. Anatomy and physiology does the same thing. A lot of stuff in anatomy and physiology, it's the same substance, the same structure, multiple names. This is no exception to the rule here. Notice that it lines compartments that open to the external environment, and then it gives you a list of different examples, like the digestive system. The digestive system, or the digestive tract, I should say, has two openings, one at the oral, one at the anus. I think we pretty much, figured out how that works. But the thing about it is, because you have a tract and it has an opening at both ends that happens to be exposed to the external environment, it has a mucous membrane wrapped around it. Respiratory tract, same thing, uses the oral cavity and the nasal cavity, your mouth and your nose. So it's got a mucous membrane. All of these tracts have mucous membranes in them. Why? Because mucus is sticky, and because of its sticky nature, it catches debris and pathogens. It can either stop them, impede them, or just slow them down. So it can stop and impede a substance, or stop and impede a pathogen, or it can at least slow it down. That's the job of mucus. So you have mucous membranes there just to slow its advancement down. Serous membranes, they make something called a serous fluid. It's very watery. It's not like mucus, which is a very sticky substance trying to catch things from getting in. Serous membranes make something that's watery. But the unique thing about this watery fluid is the fact that this watery fluid is also slippery. It has these proteins in it that makes it very slick. Almost as if it were slimy, but still a lot more watery. Because of this, it reduces friction between two substances. You usually have serous membranes in between internal organs. This is very important because when you're lying on your couch taking a nap and you start rolling around and stuff, the internal organs within you begin to slip and slide against one another. They begin to move against one another. And instead of having two extremely important internal organs rubbing against one another and producing friction, instead of that happening, what they do is that serous membrane keeps them from creating that friction, because whenever you create friction, you lead to heat and damage. And when you lead to heat and damage of a tissue, you lead to inflammation. And when you have an inflammation, that can lead to a lot of disorders, right? So don't forget that. Serous membranes are extremely important. They allow different tissues and different organs and different things within your body to rub against one another without causing damage. Because if you don't have a serous membrane, you don't have serous fluid. If you don't have serous fluid, then you allow two substances to rub against one another, which then leads to friction. And if you create friction, then you lead to the breakdown and you lead to breakdown of the tissue, and you lead to heat, which then leads to inflammation. And if you get inflammation, then you have the onslaught of other disorders that are on the way. Cutaneous membrane is a big fancy name for skin. Did you know your skin is a membrane? Yeah, it is. It's categorized as a membrane due to the fact that it has epithelial tissue and connective tissue. That's right. Your skin is made up of epithelial tissue and connective tissue connected to one another. And when you break down the skin, you have the epidermis, which is made out of epithelial tissue, and you have the dermis, which is made up of areolar connective tissue, as well as dense irregular connective tissue and adipose tissue. 3 different types of connective tissue, all involved in your dermis. How you like it now? So yeah, you got the epidermis and you got the dermis, aka epithelial tissue layers and connective tissue layers, all bundled together to make your skin. And please do not underestimate your skin. Your skin is a wonderful thing, man, because your skin, acting as a cutaneous membrane, actually keeps your internal organs separate from the external environment, which is extremely important. Because if you see some of this nasty stuff that's out here, you really want your skin there. That's why people can die from 3rd-degree burns. It's not the fire that killed them sometimes. Oftentimes it's the infection that that person gets because there's no cutaneous membrane, there's no skin left to keep those pathogens that are floating around you and me from getting inside of you and me. And another thing also that they die from, other than infection, is they die from dehydration, because your cutaneous membrane is actually keeping water inside of your body. When you remove the cutaneous membrane, the skin, from somebody, it allows them to dehydrate. The water just evaporates right out of their body. The last membrane is synovial membrane, which the synovial membrane is really, it's probably the most incomplete membrane, because you've got epithelial cells and you've got connective tissue, but it's not as much as the other 3. But nonetheless, synovial membrane is a membrane, but you don't find synovial membranes like in between your stomach and your spleen or something like that. That's not how it works. Instead, you find synovial membranes in between movable joints. All right? And I'm having to stress that it's in between movable joints. You're not going to find it in between immovable joints. Like the bones in your skull, those actually have joints. Yeah, seriously, you have joints in your skull. They just don't move. So there's no synovial membrane up there in the roof of your skull. However, the bones in your fingers, those phalange bones, those guys where your knuckles are, those are joints, and you have synovial membranes in them. The synovial membranes, just like mucous membranes make mucus, and just like serous membranes make a serous fluid, synovial membranes make a synovial fluid, and it reduces the friction in between the bones so that your bones can move, so that your joints don't hurt. Now, there was one other thing I kind of wanted to throw in here, even though we just talked about membranes, and I wanted to talk about 3 words. Atrophy. Atrophy is the shrinkage of tissue. A lot of times atrophy happens because you're getting older. Sometimes atrophy happens because, a tissue fails, it's no longer working. Or atrophy occurs because you're no longer using that particular tissue. For example, can a very disappointing heartache that some people have is when they finally get a chance to see an old high school person that they had a crush on, or a college person they had a crush on, and they finally get a chance to see that person, and they're like, oh, where'd all the muscles go? Well, it's not necessarily their fault. When they were in college, their job was to go to class, and they probably worked out, 4 or 5 times a week. They ate at the cafeteria multiple times a day and lift weights the whole time. Now that they're out of college, they're no longer doing that. And so because those tissues are not being used the same amount that they used to be used, they start to experience atrophy. And believe it or not, muscle tissue and bone tissue can begin to reduce. The muscle cells begin to experience atrophy because you don't have the need for them like you used to. Another word that I wanted to introduce you to is necrosis. Now, necrosis is tissue death or cell death, and it can happen because of a lot of different things. Sometimes cell death actually happens, and when you get to 211, you'll talk about cell death happening due to the fact that a virus has gotten inside of a cell, and that virus kills that cell. Other times you'll find where a cell has become infected with a pathogen, and your own immune cells destroy that infected cell, and you experience necrosis. And I'm about to get gross real quick, and it's about to get real gross, it's about to get real nasty, and if you don't like gross, nasty things, you're probably going to want to stick your fingers in your ears and go la 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 for a little while. When you have a chest cold and you're coughing up that stuff called sputum, and the doctor will oftentimes tell you, you'll go in, you'll say, Doc, I felt horrible, coming in because you're feeling sick. And the doctor will ask you, all right, tell me what's wrong with you. And you say, well, you got this raspy voice and you're spitting up fluid from out of your chest. And the doctor will turn to you, and she or he will look at you and say, what color is the sputum? What color is the stuff that you're spitting up? And based on that color, they can assess what stage you are in that chest cold or that respiratory infection. And the reason why I say that is because when you spit up that stuff and it's yellow, green, or even brown, what you're looking at is you're looking at tissue in your respiratory tract that's dying. It's died. Some of it is because the cells were unable to get any nourishment, and so they died. Some of them are because of the stress and trauma of being sick, and then some of the cells are dying because they're being attacked by whatever pathogen is making you sick, and then the rest of the cells are dying because your immune cells are coming through and executing infected cells with an extreme prejudice. There's a war going on in your chest. An example of necrosis to an extreme is gangrene. And when you look at gangrene from a clinical view, gangrene is when you have necrosis of a different tissue or a different body part because you cut off blood flow to a tissue. Now, I really wanted to hit on this one before we closed up this review because I feel it very important that you understand a concept that oftentimes people miss. And that concept is this. In order to keep tissues alive, in order to keep cells alive, they have to have nutrients. I mean, if you were raising animals and you didn't feed the animals and you didn't give the animals anything to drink, the animals would die. Cells are the same way. You don't give cells anything to live, then they will die. So if you cut off blood flow to any living tissue in your body, that tissue will die. That's what happens with gangrene. That's why you don't have to be caught in a blizzard to experience gangrene. All you got to do is just have blood flow restricted from an area of the body, and then that winds up having that person experience gangrene. And that's why sometimes you see people who have other diseases and disorders experience gangrene, and they wind up losing toes while they're in the hospital, losing fingers, or even losing a lower leg. It's because that other disease or disorder cut off blood flow to an extremity. Toes, fingers, arms, legs. Blood flow is cut off from circulation, and before they know it, the cells there die. And it doesn't take long for cells to die, to be honest with you. Once you cut off blood flow to them, and within a matter of a very short period of time, that person can lose a toe or toes or even lose a foot in that situation. So that wraps up our review. Just wanted to make it really quick, really short, to the point. Hopefully we'll be able to talk again real soon, and I look forward to seeing you guys at a latter date. So take it easy. You got any questions, you know how to find me. Peace.